Hi, this is Jason with Liquid Instruments. This is the final video in a three-part series about encoding and decoding digital data using different instruments available on Moku devices. In parts 1 and 2, we encoded and modulated digital data using the Moku Pattern Generator and Waveform Generator. Right now, we are viewing this amplitude shift keyed data on the oscilloscope. Today, we're going to use the lock-in amplifier instrument to demodulate this ASK data and recover the original digital pulse sequence. We're still going to be working in multi-instrument mode, so we'll return to the system build screen, and we will select that option. We're going to put the lock-in amplifier in slot 1 for the demodulation, and the oscilloscope in slot 2 so that we can look at it. Since the signal is originating from another Moku Go, we need to make sure that these instruments are connected to the analog front end. So we're going to have input 1 connected to channel A of the lock-in amplifier, and we're also going to send it to channel A of the oscilloscope. Output A of the lock-in will go to input B of the scope. We're also going to send output A of the lock-in to the output on the analog front end, and we'll show why we're doing this in just a minute. Let's click Apply Changes and wait for the configuration. We're going to open the instrument screen for the lock-in amplifier. Now we're going to run through some settings so that we can recover the demodulated amplitude of the signal. I've already optimized some of these settings. If you're doing this with your own setup, then you may have to adjust these as needed. The first thing we do is set the local oscillator to 10 MHz to match our carrier. And then we'll set a low-pass filter to 800 kHz and 24 dB per octave roll-off. So a fairly wide filter, but a sharp drop-off. We want to recover amplitude information, so we'll set it to polar coordinates and make sure the switch is set to amplitude. We're going to add a small gain of 10 dB and a voltage offset of minus 2.5 volts. We're also going to make sure that the output is enabled. And we can preview this demodulated output by using the probe point here, where the letter A is, and the embedded oscilloscope. And we can see that it already looks pretty good. Now we're going to click over to the oscilloscope. And we're going to see both the modulated and demodulated data side by side on channels A and B, respectively. You can see that we've recovered the original pulse sequence. Now we're going to do one last thing using the other Moku Go. We're going to click on the plus sign over here, and we're going to open a new window. We're going to select the Moku that we've been using as the signal generator, and we're going to make one change to the configuration. We're going to connect input 1 on the analog front end to input A of the Logic Analyzer. Now this signal is the one that's coming from the lock-in amplifier via a BNC cable that connects the two devices physically. We're going to click on Apply Changes, and we're going to open the Logic Analyzer. Now if you'll remember, in part 1, we set up the pattern generator and used it to produce the digital data that we then modulated onto the carrier. We can recover that original data by looking at the bit stream that's recorded by the Logic Analyzer. We're going to look at bits 12 and 13 in particular. And we see that when we scale the output properly, the pattern of the bits on 12 and 13 mimics the one that we initially encoded. What we've essentially done in this three-part series is produce a digital pulse sequence, modulate it onto a carrier, demodulate it, and recover the original sequence using a variety of instruments available on the Moku Go. I hope you enjoyed this series. Please visit liquidinstruments.com for more information, or check out the rest of our YouTube channel for more tutorials like this. Thank you, and see you next time.